Let's do a quick summary, and then we're going to go on to some really, really cool stuff. Okay, so let's summarize. An exponential function. Yeah, the exponential means the x has to be in the exponent. Now, there are some conditions here. C can't be equal to 1, and C is always greater than 0. Yeah, we'll get into that as we go through this course, okay? Be still. So check this out. If C is greater than 1, the function increases. Well, you're probably saying to yourself, I don't get that. Just pick a value for C that's bigger than 1, like 2 to the power of x. You know and I know the graph of this guy starts here and comes up and goes like that. You know that. But look what happens when C is between 0 and 1. In other words, C is a fraction. Pick a value. For example, like 1/2 to the power of x. You know and I know that this graph goes this way, right? Okay, so it's increasing when this value is big, and it's decreasing when that value is a fraction greater than 0, less than 1. Okay, now here comes a couple other important aspects of this. Exponential functions in this form have a domain. Yeah, x can be anything you want, but the range, of course, because of the horizontal asymptote, always has to be greater than 0. No x-intercepts, they do not exist. And the y-intercept, of course, is always going to be 1. Ha! So much fun. But I got a question for you. Now I want to go back to this kind of idea right here, where I said that C cannot equal to 1. Why? Why? Tell me, what does a graph look like if C was 1? Let's write it out. Y equals 1 to the power of x. It's going to be a pretty boring graph. Think about it. Do a table of values. Here's your x values from -2, -1, 0, 1, 2. Check this out. You're going to laugh yourself silly. Watch this. Always start on the 0. 1 to the 0 is 1. 1 to the 1 is 1. 1 squared is 1. 1 to the -1 is 1. Is 1. Oh my goodness, this is so incredibly boring. This doesn't show any growth or decline at all. And that's one of the reasons why you can't have an exponential function if this value up front is 1. Boring, right? Okay, so let's put this to use. I got a great question for you here. This says, find me the equation. Find me the equation of the exponential function given this data or given a graph. In other words, what you're after here, folks, is you want to find that C value. Okay, how do we do it? Simple. Easiest ones to work with is always the number 1. But what if you don't have a number 1, like you have in this particular question? Look, you got a table of values. Look, x of 0 doesn't give you any information because you know whatever the base is. This could be a base of 17 to the power of 0 is still going to give you 1. That doesn't give you any information at all. So don't use the x equals to 0. But how about this guy? Oh, interesting. So let's check this out. If y equals to the c to the power of x, you're telling me this y, which is 3, equals to c, which we don't know, to the power of -1. Well, we can solve that. That's easy to solve. That's actually really easy to solve because c to the -1 just means that this is 1 over c to the 1, or just plain old 1 over c. Look at this. Cross multiply, you have 3c equals to 1, divide by 3, c equals to 1/3. So what's the equation? Y equals to 1/3 x. And does that work? You betcha. Put in a -2. This causes this. Remember, this becomes y equals to 1/3 to the -2. Means to flip it becomes 3 squared, which is 9, which is what you have. See how it works? Super, super cool. Okay, with that in mind, let's go on to the next question, which is a graphic question. I'll write up the answer again here so you can see it. Y equals to 1/3 x. Nice. Now, look at our next graphic question. Of course, this is going to go through that point of 1, but how about this? Isn't this, look, plug it in. Wouldn't this be y equals to c to the power of x? We're trying to find the c value. Well, if you think about it, that's at x equals to 1. So this is c to the power of 1. Y happens to be 5. Oh my goodness, that's tough. C to the power of 1 is just c. So guess what? C equals to 5. This, of course, is rising, and you can see that it's rising. So this means y equals to 5 to the power of x. Boy, that's not tough at all now, is it? Okay, let's do the same thing again, but for this graph. Notice how this one's now is falling. So start dealing with the negatives. Look at this. Look at this. If you deal with the negatives here, you'll notice something. Y equals c to the power of x. You'll notice that at x equal negative 1, this works out to be, well, it looks like 4. 4 equals c to the negative 1, right? Which means, yes, you know it and I do, 4 equals to 1 over c. Cross multiply, 4c equals to 1, right? Divide by 4, c equals to 1/4. This particular graph is y equals to 1/4 to the power of x. Oh my goodness. Wow. Knowing a little bit about the rules of exponential functions, you can solve a lot of stuff now, can't you?